Good afternoon, everybody. Can I just ask, are there any pool operators in the room? Is everybody trade, or is there any operators? Oh, right, okay, so we've got a mixed audience. Good, thank you. All right, well, the title is Smarter Filtration. I know it said SmartEd Filtration on the title outside, so a bit of a typo. So I don't know whether you've seen or experienced ceramic membrane filtration before, but we're going to just go through just a few of the basics about what is it and how does it work. We're going to look at an installation case study from a job I was involved with last year. We're going to look at some of the market challenges for CMF technology as well, and how they can be overcome, and some of the new developments that we've got arriving in the next year. So without further ado, so what is ceramic membrane filtration? It's basically a tube, if you like, a formed tube from silicon carbide, and it's like a honeycomb structure throughout the tube, and the surfaces of that honeycomb are coated with a sintered silicon carbide surface, a much finer surface. So that's how we get down to a very fine filtration grade. And that's done at very, very high temperature in special ovens in an inert atmosphere. So it's quite an expensive thing to produce, but once it's produced, it's extremely robust. Some of the properties of ceramic membranes, it's got the highest flux of any membrane material, so it's very, very porous for water. It can pass through very easily. It's also chemically inert, so we can throw acids and caustic at it. It's not going to degrade or oxidize. It's thermally resistant up to 800 degrees as well. So, and for that reason, it's got an extremely long lifespan. So we expect around 30 years, something like in pool applications. If something does happen to that membrane and it gets terribly fouled, then the membrane can be removed and always baked in an oven at high temperature, and it will restore it to its original condition. So yeah, it's an extremely hard material, second only to diamond, really. So you can see how resistant and how hard that is. And silica sand in filters is typically about 7 on the Mohs hardness scale. So, and it's got a very high surface area. So each membrane element has got a very high surface area. So how does it work in practice? How do we push water through that membrane? So typically in a membrane system, we'll push in the unfiltered pool water from the bottom of the membrane, and it's what we call dead-end filtration. So you can see at the top edge of that, where the black lines are going up, is capped off, and all the water has to permeate through that ceramic membrane, and the blue arrows show the water going out. So it's in at the bottom, out at the top. So the good thing is that all the water has to go through that membrane. It can't be bypassed. Unlike perhaps a sand media filter, where sometimes you can get fissures when the filter isn't performing properly, and some of the water can get through without being filtered. As in this situation, it's 100% filtration. So we can get down to about 3 microns, so slightly lower with a standard membrane system. But of course, in swimming pools, we know that a great deal of the pollution in pools is below 3 microns in size. So we'll come to that a little bit later on. So we have a method to deal with that. But that's pretty good. 3 microns, that will make sure that we're filtering out things like cryptosporidium. And as I said before, 100% of that water's got to go through the membrane. So there's not much chance of crypto getting past that membrane. Backwashing is a bit different on these filters. It's required probably several times a day, every few hours, or just depends on the bather loading of the pool at that particular time. But the backwashes are done frequently, but they're only short and they only use a very small amount of water. And then occasionally we'll need chemical cleaning, because perhaps after a week or so of use, the membranes do get a bit greasy with all the body fats that are in the water. So occasionally we'll do a chemical clean using a caustic chemical, and maybe occasionally an acid clean if there's any hard water deposits. So that might be something that you do once every week, once every 2 weeks to restore the membrane fully. The advantage though, if you're backwashing every few hours, for example, that means you're not holding on to all the organic debris and dirt that collects in a normal sand filter. So that's a big advantages, and it's one of the reasons why these systems are pretty good at lowering combined chlorine, because we're ejecting the dirt on a regular basis. We're not holding on to it for a week or for 4 days, so the chlorine doesn't get a chance to carry through some of its reactions. So all these individual membranes then are assembled onto what we call a rig, and that rig is sized according to the pool capacity, and each membrane can filter about 15 to 19 cubic meters an hour, just depending on the loading of the pool and the temperature. So the inlet for these filters is on the bottom. The water travels up through the membranes and comes out at the top. Very simple. And then backwash water is ejected through that 100 ml pipe at the bottom. So it offers some advantages being packaged like that, because you can virtually bring it to site. Everything is pre-assembled on that skid, and you're just connecting your pipework in and out. A bit of electrical wiring, and it's pretty quick to deploy. But I'm going to show you just one of the jobs we did last year, which was a bit more difficult. Only difficult because of the access on the site. Okay, so yeah, just before I do that then, some brief advantages of that. So we've got filtration down to quite a good level. We can go a little bit further, and we'll cover that soon. We've got very low maintenance, so there's no filter media replacement or inspections needed, because we haven't got a filter bed that can deteriorate in the same way. So you can all those costs associated with that are avoided. Again, we said it's got daily backwashing cycles, so it doesn't retain the pollution. The other good thing is, because we're only backwashing quite small amounts of water at a time, 60 litres per membrane, for example. So there's very little fluctuation in pool temperature, because it's happening little by little every day. So no big volumes of water for dilution required. It's not going to lower the temperature of the pool. And then we've got the automatic operation. So we've got sensors, pressure sensors and things like that on these systems, so that we can automate the backwashing, automate the chemical cleaning. And so there's very little operator intervention, apart from doing some daily checks on the plant to make sure everything's operating properly. And then the other big benefit is energy efficiency. Because we are backwashing these filters regularly and expelling the dirt, we're not getting high pressure buildup in the filter. So that allows us to run circulation pumps very efficiently. So we can turn over a higher volume of water at lower pressure. So there are good opportunities to save energy with these systems. So there are a couple of different manufacturers for these membranes. In the UK, Lictech is a big brand, and also Saint-Gobain. And I think FT Leisure do a lot of the Saint-Gobain systems as well, and they've installed quite a number of these systems into brand new leisure centres. So you'll see a couple of different manufacturers for the membranes, and the actual style of how they're mounted or used, it may vary from company to company. So I'm just going to show you a little bit of the practical side of getting these things in and out. So this was a pool last year, a client I have in Tralee in Southern Ireland, Southwest Ireland, and it's a privately owned leisure pool at about 745 cubic metre capacity. It's quite a big pool. It was built in the early 90s, so that the filters there had come to the end of their life, but they were in a very difficult location under the pool, 3.5 metres down, with a very, very restricted access. So it was technically quite difficult to get equipment in and out. There was virtually no chance of putting steel vessels back into that site unless you were going to fabricate them on site, which was also very costly. So we had to deal with this refurbishment, and we had to get all the equipment down through this narrow drop at the back of the building. And it was about 3.5 metres high and probably about 4 metres square. Very, very little space to get in and out. So we had to extract all the vessels through there, cut them up, remove them all, install 2 new membrane systems with 9 membranes on each of the 2 rigs. New circulation pumps were going in, new strainer baskets for this, and a new chemical system. And we had to get all this done in 4 weeks closure period. So it was a bit tight. But just to show you some of the... quite noisy. It was quite noisy. You can see it's like the devil's kitchen in there. So we had to get all these vessels cut out first. Removing the concrete was extremely difficult because the concrete in the base of those filters had set rock hard. As you can see, we had to chop all the plant up, remove it all. Some big tools needed to get that concrete out, unfortunately. So it was technically a bit of a mission. And then the new rigs arrived, nicely pre-assembled, and we had to get those down into the pit via crane as well. So, yeah. And we had new strainer baskets, very large strainers going in, and these strainer baskets are big because we're filtering down to 750 microns. We're doing it as a bit of a pre-filter for the ceramic membrane system. So then got the system up and running pretty quickly once the rip out had been completed, and that's how basically they went in. And we have an automatic system there for monitoring the pressures and flows and programming all the backwashing. We filled the pool, and a couple of days later the water was nice and crystal clear, ready for reopening. So that was Christmas 2024. So yeah, luckily just about managed it in the 4-week window. So that installation, I'll just give a shout out to these guys because they worked very, very hard to get it done, and that was Pool Technical Services based in Bolton, and they were assisted by a company called Southwest Engineering, who had all the big boys' toys to get the concrete out and the steel out. So a very helpful company. So all was well until February. After a couple of months of that pool running, we began to get dull water, bit of a concern. The filter pressure started to increase, and combined chlorine levels started going up. We tried additional cleaning of the membranes. I could do that remotely. I was logging on, doing that remotely, trying to get maybe it's just the frequency of the cleaning. Unfortunately, that didn't work, and the backwashing frequency and the water usage increased as well. So a little bit concerning. So as you can think, I was back on a plane fairly quickly to investigate what was going on. So all the equipment was working correctly. We couldn't find any anomalies with the water quality either, particularly apart from the combined chlorine being high. What we did find is that the customer had changed the chemical they were using for cleaning the membranes, for doing the caustic clean, and it wasn't the same concentration. So I quickly thought, problem solved. We'll increase the dose rate. We recalibrated the backwashing, the cleaning cycle, and it seemed to be performing very, very well. Unfortunately, that wasn't the answer. So we had to, even though we'd increased the dose rate, so the pressures were still rising much faster. And after doing a little bit more detective work, as you can see, that water's pretty poor. It's not acceptable. You could only see a few meters through it. So with doing a little bit more investigation work, we decided to increase the flocculant dose rate, but that still only had a very limited effect. And we discovered that there's something affecting the flock, something preventing the flock from working. So we did an early morning visit to the pool, very early morning visit, and discovered that the cleaning staff were using detergent-based chemicals to clean the pool decks, and they were swilling them off the sides of these jetties and things like that, and it was getting into the pool, and that had been happening for a couple of months. And just back calculating what they'd used, we reckon there was probably about 10 litres of concentrated cleaning product in that pool. And that just shows you the detrimental impact it has on water, on filtration, because it's undoing everything we're trying to do with flocculants, everything we're trying to do with the filters. That detergent is trying to wash that debris through the filter. So it wasn't possible to close the pool. The water clarity wasn't that bad that we had to close the pool, and the pool had only just opened, so it would be a bit of an embarrassing situation for the client. So we banned the cleaning products. We increased the flocculant dose rate to assist the removal of contaminants, And eventually we started to get a huge amount of debris coming out of the water. Once we'd done that, we increased the backwashing and just continued that, really, to try and get rid of that water. And you can imagine it's a bit like having a tin of white paint. If you get a blob of black paint in that white tin, it's going to take a lot of white paint to get it white again. And that's what we were faced with. So the remediation, really, that filtration, that frequent backwashing, topping up, it took 3 months to fully recover that pool. So it just demonstrates how severe the impact of detergents is on filtration. And that goes for any kind of filtration, sand filtration as well. So it's just something to be aware of if you're commissioning a new system. But eventually it did come good, and the water clarity came back as it should do, and it's superb clarity. And this is a very busy pool as well. Maybe during the week they might only have a couple of hundred bathers per day. Then at weekends they get hammered with up to 12, even 1,300 bathers on a day. So you can see the clarity is a lot better. So the result was, now we got the pool under control. The combined chlorine readings were coming down. Typically during the day you start off at 0.3. They might creep up a little bit during the day. And then overnight they fully recovered again, because again we're not holding on to any of that dirt and debris. So, and that was without using any UV. So it's quite a good result. There's no irritation or odor problems in the atmosphere, so that indicates really that nitrogen trichloride levels are pretty minimal. Because that's one thing, you know, that if your eyes are stinging and you've got that horrible chlorine smell, you know you've got a nitrogen trichloride problem. So again, and this is even with bathing loads up to over 1,000 people a day. Savings-wise, because of the efficiency of those filters and all the other length of pipes and elbows and T's and valves that we managed to get rid of, the energy consumption or the energy required to push that water around the circuit had reduced quite considerably. And we'd also installed some energy-efficient Grundfos pumps. So we got almost cut the energy bill in half, really. So saving around about 84,000 kilowatts a year, or 19 tons of CO2, probably around about 18 to 19,000 euros in cost just for circulating the water. So it's made quite a difference. Water consumption, so really that's still up for debate yet, because it's we've only had sort of 6 months steady operation due to all the problems with the detergent. So the jury's still out on that. And I always say I'm a big fan that pools should be properly diluted, and whatever you can claim that you can save with filtration, really at the end of the day you should still be diluting about 30 litres per bather, come what may. So I don't get overexcited about saving a lot of water, but we can save energy, we can save chemicals, and we can produce a much better water quality. So chemical savings around about 5,500, and again that's with the first few months of the year being very poor performance. So we expect a bit more savings on chemicals to come through this year. Okay, so new flocculant development. So this was a new flock we deployed at the Aquadome first time. It was used outside Spain. So it was developed by Oxidine and Wapatec, an Austrian company. And it's designed specifically for membranes, because if we try to dose PAC onto silicon carbide membranes, it just blinds up the membrane. It just sticks to it like crazy. So a new flocculant was needed that creates a long chain porous flocculant. So basically we can pull out all those particles below 3 microns, but not blind the filter, still keep a porous filter surface. So that was the aim, and that was very successful, and we're going to be using that flocculant on all future systems. So yeah, it's what they call a natural blend of silicious aluminate. So it's like a byproduct of the salt mining process in Austria. It comes out of the Austrian Alps. It's like a salty clay that's refined, and it has some very interesting properties for flocculation. So that allows us to remove all those particles we were talking about that are below 3 microns in size, and there's a substantial amount of those in any pool. So 3 microns is great, but it's not good enough, so that's why we use that particular type of flocculant. And because of the long chain, the porosity of that flock, it helps to keep the filtration pressure more stable. So we can have longer filter runs, if you like, and still pull out an awful lot of debris. So looking at that, so that's existing systems. So what are the market challenges for ceramic membranes? So really, one of the big ones is cost, capital cost. At the moment, the way the systems are produced, they can be significantly higher than for sand filtration, but the whole life costs are significantly lower. So yeah, but it's having that capital up front really to be able to purchase these systems. So it's a big challenge. There are lots of smaller facilities in the country, sort of swim schools, hotels, temporary pools even, where this technology could offer some really great benefits, because a lot of these pools, like swim schools, are absolutely hammered with bathers all day long. Their little sand filter can't cope, the water quality is poor, and ceramic membranes would be a good answer to that problem. But again, it's cost and space. A lot of these little plant rooms might only have one sand filter in there, and we've got to try and get a ceramic membrane system into that pool, so it's quite difficult. And the final one is that when you install the membrane system, obviously it's a more expensive piece of kit. We want it to be very, to perform optimally, so you get maximum benefits from it, financial benefits, but that takes time and engineer experience to do that, to optimize the backwash frequency, the pressures, the flow rates, things like that. So it takes a bit more involvement, and again, that all increases costs. So those are the challenges that we've tried to look at and address. And over the last couple of years, I've been working with a Spanish company called Oxidine, who have been deploying these membrane systems in Spain for nearly 14 years. And over the last few years, they've sort of redeveloped this technology and included some newer technologies to improve the situation. So one of the advancements is what they call their new Keramikos healthy pool system, which is, instead of having large membrane racks, they have a revolver style rack that's very space saving. So where the filters rotate into a backwash position. So being able to do that eliminates 5 valves for every membrane. So that's quite a substantial amount of valves. And when you think you've got, like the system in Ireland, where we've got 18 membranes, 18 times 5 valves, that's a lot of cost. It's a lot of potential problems that could occur in the future. So if we can get rid of these valves and simplify the system, it's going to make a big difference. So that's the first big advancement, really, is compacting the size of it and eliminating the need for all these air-operated valves. Each membrane is located then into a backwash position. Because of that, we get lower friction head loss as well, because the water's coming in at one side, going out the other. It's not changing direction through different manifolds and valves, so it simplifies the route of the water, the flow of the water. So we get lower friction head loss again. And then finally, with all that weight that we've taken out of the system, we now can get a system that weighs less than 500 kilograms per square meter, which means it can be installed on mezzanine floors without having to have any additional reinforcement. So typically for a pool for 125 cubic meters of turnover, we can have a filtration system that will do that, and it might only measure 1.7 by about 1.1 meters, very compact. So you can see, even if you had a bigger pool, 2 of those systems maybe, it's still very compact. The next level, really, is where these new systems are being introduced this year, is they're going to integrate some new technology to try and make a more, let's say, more holistic system, looking at not just the water quality, but the air quality as well, and trying to optimize the whole water treatment system. So the first step in doing that was using this new chloramine technology that's been recently developed, and that's for the live monitoring of nitrogen trichloride in the pool air. It also measures CO2, humidity and temperature, and that can be used then to measure the amount of nitrogen trichloride in the air and even optimize the HVAC systems. So perhaps when the pool is quiet, not many bathers in there, do you really need to have so much fresh air dilution going through that pool hall? Could be reduced maybe if the air quality is good enough. Again, perhaps if you're getting swimming clubs in or you're very, very busy, nitrogen trichloride is going to increase. So we'd want to perhaps increase the HVAC system output. Maybe you want to speed up the filtration system and start to anticipate these higher bather loads. So that's one route. And all this connects back to a cloud system. So the second one to optimize is using this new OxySafe pool occupancy detection. So this is using laser cameras to anonymously track bathers in the pool. So why do we use that? Well, we can use that for a couple of purposes. Again, to ramp up the filtration in anticipation of the bather load. So as soon as you get a big group of bathers arrive in the pool, that can instruct the filtration system and the disinfection to speed up a little bit. It can also be used to decide where to deploy your freshwater dilution. So for example, if you had a multi-pool facility where you've got 2 or 3 pools in a pool hall, or where you've got these big spa facilities with lots of different pools of water, how do you know where those bathers are going first? How do you know which pool they're going to enter and where all the pollution is going to land? So this system allows you to track bathers even from a changing room to the pool. And so you know which pool to deploy your freshwater dilution into. And again, it's a good way to track numbers, bather numbers as well, you know, just for your records. So that's the second advancement. And the third one is using predictive AI. So as I said before, all these systems now are connected to the cloud. We've got about 40 pools in Spain, one in Southern Ireland that I did last year, being connected to the cloud, and all that data is being recorded and used to train what we call this new predictive or adaptive intelligence. So we can use that to optimize the performance of the filter, the frequency of the backwashing and the chemical cleaning, because we've already learned the situations that exist in all those 40 other pools of various types and sizes. So that's been a big project for Oxidine to get the right engineers on board to make this AI learning ability and make it deployable to each system. And each system feeds into the cloud its data. So it's a constantly evolving system at the moment, but it allows us to optimize the performance of the ceramic membrane a lot faster. We don't have to keep going back to site, doing tests, making changes, because we already have a lot of intelligence on how these membranes should perform. So so it makes the operation and the setting up of the system a lot better. The good thing is that all the existing systems out there can have these technologies deployed. Yeah, we can use those 3 different tools to adapt all the existing systems. So just quickly in summary, because I appreciate time is running out. So yeah, using that, we can get the capital cost down, and the idea is to get it down within reach of small pool operators. And Oxidine are also developing a new membrane system specifically for very, very small pools like hydrotherapy and swim schools, where the membranes can be put on a platform that's about 600 by 600, so extremely compact. So that will probably be something that's going to be available early next year. We're working on that. So even with the new systems, we're looking at a space requirement of probably 50% less than that for traditional sand filters, using this new revolver system. We've got the automatic operation and AI learning. We've got more stable pool water temperatures because we're not introducing huge influxes of fresh water. So lots of sort of different benefits. Lower maintenance costs because we're not looking at replacement media or relining vessels. Reduced chloramine levels, again, because we are getting rid of the organic pollution in the pool on a regular basis. And then greater efficiency due to the improved hydraulics, both of the filtration pressure that it operates under and also all the pipe work that we've managed to remove from the system. And then, just as a final note, it's related. They're also developing this same technology, membrane technology, to make a pool water, or let's say recovery system for water in wet leisure and wellness facilities, whereby we can recover all the grey water from the showers and sinks and things like that, and extract the heat from it. And so they're looking at doing that. We've already got examples of these systems running in Spain, and hopefully they'll get introduced to the UK pretty soon as well. So, and just to say, my little advert to say that, yep, I'll be assisting Oxidine in the UK to help get this technology deployed over the coming year. Thank you for your attention. I hope you found that useful. And any questions?